Hello guys, good morning. Let's wait for others to join. Please confirm if you can hear me. All right, everybody. I think we are good to go. Please confirm you can hear me so that we start.
We can hear you, sir.
All right, great. Okay, welcome again, everybody. I'm going to share my screen now. All right, let's go. So today we'll be talking about inheritance and classes, and this would be the last JavaScript concept, core JavaScript concept that we'll be looking at before we get into Node.js. All right. So I saw someone's message on the Node.js group ranting about why we haven't gone into Node.js yet. So to pacify that person, by next week we're getting into Node.js. All right. So let's continue. All right. So inheritance. All right. For us to actually understand the concept of inheritance, I think I have, to an extent, explained this concept in passing a lot of times during our classes. But today we're going to thoroughly look into it. And for us to understand, we need to understand objects, all right, in JavaScript. We need to understand objects in JavaScript. So, how does objects, work, all right? Or how do we create objects in JavaScript? So there are different ways we can create objects. For instance, we can just say const user equals, and then we give the user a name. That's the Austin. Then give the user a surname. That would be Soluka. And then give the user an age. That would be let's say 18. And then we would just say let's just say get quote. All right, so get favorite quote. So none, also the log, none for now. All right, so yeah, so this is a method, all right, in this object. So when a
Hello,
function
team. Hello, team.
hides, yeah,
So I'm sorry to interrupt, but I wanted to get something clear. Some of the researches I've done or tutorials I've watched when creating objects on the key or property part, I always see it is always wrapped in quotes. So I don't know if that is a convention.
okay, it's not. All right, so we'll get, I think when we talk about, when we start dealing with returning data from an endpoint, I think in Node.js would visit that. That's a JSON format. All right, we
Oh,
could write it
okay.
like that, but it's a
Yeah,
JSON
okay.
format. It's not the actual object format. All right, so
Okay. Thank you very much.
yeah,
Sorry,
okay,
can I ask something?
okay. So this is the last question I'll take during my session until it's time for questions, so that I can, so that I don't break the my thoughts flow. All right, so but you can go ahead.
Okay, I thought in methods, like, is there supposed to be a colon? Like, it's supposed to be get quote bracket, but you did get quote colon bracket.
All right, so those are just syntax variation. All right, so there are different ways to write methods in objects. Okay, I could have done function like this. All right, and this still works. I could have done arrow function. That's what I just did now. I could also have done this, think, yeah, like this, and it will still work. All right. So they're just syntax variation, and this is what I prefer to use for the purpose of this class. All right. So in programming in general, you can do one thing in different ways. All right. Okay. So yeah. So when a function, this is a function actually, it's an arrow function for those who are not familiar with it. So this could be like const get quote. If it were outside an object, I would have written it like this. All right, so you see that this is a function, okay? But when you have a function in an object, it is called a method, okay? So I have a method here, and this is an object I've created. And you could simply console log that object, and then you see it here, all right? So this is method one, creating an object. So there's another method we can use to create an object, and that is by using constructor functions. Okay, so let's say we want to create the same type of object, but we need more of it. All right, we know that we are going to be creating many users, and those users would have the same properties. Okay, so every of our user is going to have similar properties. Okay, so what we could have done is simply copy this, and then we'll have user 2, and then we'll call user 2 Patrick. Okay, and then Patrick Solomon. Okay, Patrick Solomon sounds like somebody who is older than Austin, so gonna be 45. So we'll get a quote. Say life is short. Do what matters. All right. I say it's an elderly man. Okay. So we now have two users, first user and the second user. But if we want to improve this code, what can we do to improve this code? There's something I would have loved to show you guys quickly, but that if I have the time. But the truth is, when you have more code in your script, right, it's going to impact on your performance. It might be a negligible impact, right? But then as your code base grows, the impact becomes more visible or more non-negligible, right? So the impact begins to be felt. Okay. So it is mostly to your advantage if you can write less code to achieve the same thing. All right. There are a few exceptions to this rule, but generally, if you can write less code, all right, and I would say avoid repeating yourself, then you become a better programmer. Okay. So you become one step better. So how can we improve this code? What if we have a prototype? Okay, I'm going to call it a prototype because what it means in this context of my current explanation is like a blueprint, all right, blueprint for other objects. Okay, that's what I mean by prototype. So we're creating a blueprint, all right, and how can we do that? We can say function person, okay, and then this is a function. Now, if you are being attentive, you'll notice that I am naming this differently from how I would name a function. We know normally the naming convention for functions, it's I think almost similar, if not entirely similar with naming convention for variables. Okay, so if you have one word, it's supposed to be in lowercase. If you have more than one word, then camel case. All right. So, but in this case, you see that I am changing that. Okay, and then giving this guy an uppercase. Okay, and why is that? It is because this is a constructor function, and this is a way to indicate that it's just a convention in JavaScript. If you're writing a constructor function, the difference, what tells a user that this should be treated as a constructor function or used as a constructor function, is that this is going to be capitalized. All right. So when we start writing classes very soon, you'll see that we'll still retain this convention for our classes. All right. So this is our prototype of our constructor function. And then we want to take in a few things. All right. So we want to take in name, surname, okay, and age, and then quotes. Okay. So I would say quote generator, or let's just say quote function. Okay. Sorry about that. So this dot name will be equal to whatever you give to name. This dot surname will be equal to whatever we give for surname. This dot age, you get the drill by this time. So I think this is wrong. This should be semicolon. Okay. And then this dot get code should be equal to code function. Okay, so I hope I've written well. So now instead of doing this, all right, instead of doing this, what we can do is say const user one is equal to person, all right, and then we enter a string for name and surname, so and age of, was it 18? And then quotes, for the quotes, we use an arrow function, and then we simply just console the log, none for now, right? So this is for user one, and then for user two, we do the same thing. So, but then with different data. I think I did Patrick and Solomon, and he was 45, and he said life is short, blah blah blah. All right. So I have user one and two, but there seems to be an error. Okay, this is a two. So we'll comment this out, right? So instead of this code that you see here, this is what we have reduced our code to. All right, so I can even make this better by just simply returning that string. Instead of logging into the console, let's just return the string, all right? It's a one-liner, so we don't need those brackets. Okay, so you see it's more cleaner now. All right, so instead of this code, right, we have reduced it to this. Now it looks very negligible, like, okay, we didn't gain much. But then imagine we're trying to create like 10 different user objects. Then it begins to make sense to you. So say we have many user objects. So this would have translated to something like this, right? Having plenty of this guy. Okay, so now you see the difference. Okay. So most times when you're trying to optimize your code, it doesn't make sense initially when you have a very little code, but as your code base begins to grow, you begin to appreciate things like this. All right. So in this case, we have created two objects. So let's log them to the console. The first one is user one, and the second one is user two. If I save now, I'm gonna get rid of this. And you see how neat that code is. User one, user two, are you giving me undefined? So let's see. What do I have undefined? Okay, so we want to use the new keyword, right? Because we're treating this as a constructor. So we have to use the new keyword. Please don't forget that. If you forget, you're going to get undefined like I did. All right, so now you see person. This is a person, I will call it um, prototype, all right? So that is what we're using to create the object, all right? So I've succeeded in creating two different objects, and we can even go further to say user one dot name, the name from user one, and that's us thing, all right? User two dot name, and that will be Patrick, okay? So we can even call the code. So we can say user one dot get codes, all right, and we get that code, none for now, and user two dot get codes, and then we get that code life is short. Okay, so you see that this is another way to create objects.
So
That
T, in a
way, there's a
nutshell, this
third.
is an inheritance.
You said this is what?
In a nutshell, is this an inheritance? This is what you call an inheritance.
Well, this is us creating objects, but then the concept of inheritance um has not really started, but it is at play. But I've not talked about it yet.
Yeah, I can see that.
Mhm. Yeah. So there's another way to create objects, which is the object that creates. All right, it is object that creates. Um, so you with object that creates, what we can do is this. we have an object. Oh, I've deleted those objects. I feel too lazy to type. So we have an object. Going to put the object here. So let's call it person. All right. And then this person object is going to have these properties. So name is Austin and surname is okay. So no, we won't do this. What we'll do is we'll just say, so what are the things that every human would have? Okay, so every human is supposed to have a name, right? Every human is supposed to have a name. So well, we can even take that out. Let's just do something like, is this person a human or is a ghost? Okay, so we could say true by default, because every person should be a human by default. And then we will say get quote. So let's do get quote now. So I come here and say get quotes. It's supposed to be a function, but in this case, our get quote function, let me copy this. It's gonna say we're gonna return this dot quote. All right. And so this is our person, right? So now what we'll do is to create different instances of person. We'll do, so let me just comment this out. So we'll do const Austin. So this is Austin, and Austin will use object.create. And then I'm using person as a template. All right. I'm using Austin as a template to create, I'm using person as a template to create Austin. So let's console the log and see what happens here. Austin. You see that Austin is an object, but if we click on this prototype, you will now see that the prototype for this Austin object that we have is is object, and then it has get code and is human. So exactly what we wrote here. Okay. So with this method of creating objects, we specify a prototype for it, out of the box. Now, what does that mean? That means that every Austin object that you create is going to have access to these properties, is human and get code. Okay, so every single instance of person that you create is going to have access to is human and get code. So now I could do Austin.isHuman, and then I will get a result true. Okay, but if you look properly, right, we don't have is human on the Austin object. So let's log the Austin object again. Austin object is empty. This is an empty object. All right. So how come we're able to call this is human property on it, and then we get a result true? Okay. So let's do something. Assuming I just create an empty object like this, and I say dot is human, I will get undefined. All right. If I console log Austin, you see that Austin is an empty object, but this time I get undefined when I try to get is human. All right. So why is it that when we created the Austin object using object.create and passing person to it, I was able to, be able to get access to is human? Okay. The reason is because this person is the prototype, all right, or is the blueprint for which this Austin object was created. So by the concept of inheritance, all right, Austin is going to inherit all the properties that its blueprint has. All right. So that is the simple explanation for that. So I could create another person called Patrick, and then I'll say Patrick that is human, and I'll still get true. So Patrick still has access to this. Why? Because person is the blueprint from which Patrick was created. So Patrick is going to have access to this human. All right. So we could also go ahead and just like we can deal with Austin like every other object that we have created. So I could do Austin dot code should be equal to none for now. All right. And then if I console the log Austin now has its first property, which is code, none for now. Okay. And here comes a concept that is usually confusing a lot of developers. But I don't even think I have the time to explain it completely in this video, but I'm just going to brush through it. So if I say Austin.getCode, all right, Austin.getCode, Austin.getCode. Am I doing it right? Yeah, Austin.getCode. I currently have undefined return. So line 16 returns undefined. So let's see. Austin the get code is supposed to return this dot code. Okay, so let's see, why are we getting undefined? Why are we getting undefined? Get code is a function. So we're using the arrow function, and arrow functions does not support the this keyword. Okay. Come on. I didn't know what I was teaching now. So I go there, the debug. Okay, so arrow functions do not support this keyword. So let's see, function. It is supposed to work now. Why is it not working? So let's console. So I'm supposed to return, all right?
Yes.
I'm supposed to return from it, and then it works now. Okay. So let's delete this guy. Don't need it anymore. So what did we just do? All right. So what we just did is that we assigned a code that is unique to Austin. So if we try to, let's bring back our Patrick, and say object.create person. All right, so create Patrick object using person as its blueprint. And then let's console the log Patrick and Austin. So let's console the log both of them. So you see that Austin has a code. All right, none for now, but Patrick has no code. Okay, so both of them are different, but the truth is that they have the same prototype. Okay, the same blueprint. So both of them are inheriting from that prototype, and that's why they have access to get code and is human. All right, they both have access to get code and is human. Okay, but then if we call dot get code on Austin, we get none for now. All right, and that is because we have Austin has a code, and then Austin has access to get code. But then there's a magic that might seem like magic to some persons. This. So what is this? What does this mean? Right. This simply refers to the object. All right. That object. All right. So this means that this object, right, dot code. And what does that mean? It means that look for a code property in the object. Okay. And if we check Austin, right, Austin is that object currently. And then Austin has a code property, right? So that code property is what gets returned in this function. Okay, and that's why we're able to do what we're doing here. So if I do Patrick dot codes, all right, so we would say what is it again? Life is short, blah blah blah. All right. And if I say Patrick dot get codes, we get the codes that belongs to Patrick. That is short. All right, so that is it. So let me take some step back to explain this keyword for you guys, because it's going to be very important as we get into Node.js and we start dealing with the concept of object-oriented programming. You can't escape this keyword. It's going to haunt you. Okay, so let me just try to see if I can do justice to it. So we have an object here that we're going to call user, and then user has name. Please follow me closely. User has name. My name is Austin Asoluka. Okay. And then user has a method, right? User has a method called getName. Okay. User has a method called getName. And remember, if you are going to use this keyword, you must use function. You can't use arrow functions, all right? Or else it won't work as expected. So use functions. So I'm going to use the function here. And then what getName does is it returns this name. Okay. Whenever you see the dot notation being used, all right, so console.log user dot getName, all right. If there is a this keyword anywhere in this method, the this will refer to the object on which that dot notation is being used. Please take note. All right. So if you read online, you're going to see that this will refer to the object to the left. All right. So the guy that you are calling the dot notation on is going to be what this refers to. Okay. If you want to think about it in the layman's view, this would refer to this object, right? And you say this, you're referring to the current object where this exists. All right. That's a layman view, layman way to look at it. And it could still work for some scenarios, but that theory is going to break, at some point. All right. But something that would be mostly reliable, right? When thinking about this keyword, something that would be mostly reliable is thinking of this as referring to the object to the left of the dot notation. All right. This would refer to that. Okay. The object to the left of the dot notation. So in that case, what's the object to the left? The object to the left is user. All right. So that will be user. So this here will be user.name. And what is that? That's Austin Asoluka. So if I save, we're going to see Austin Asoluka printed to the console. Remember, we are calling the getName function. All right. Or the getName method. Okay. All right. So that is this keyword for you. This is one way you can determine what this means. All right. I'm going to leave it there for now. Okay, so if I come here and I say that, so let's do something now. Let's do first name, Austin, last name. Yes. I'm going to get an error because this looks like they're variables. Yes. And so I could say get full name. All right, so you see, get full name. Full name like that. Spell it like this. full name. Okay, so it would be choose interpolation and we get so we get first name and we get last name. All right. So we check now. Get full name, right? So we're calling get full name. We should get Austin Asoluka. So when you have maybe you have a system that stores the user's name like this, you can have a helper function that gives you the full name, okay? So that you don't go all over your code writing first name plus last name all over your code. You just simply call this helper function and then it does this for you, okay? But our focus is the this keyword. So you see that this refers to the object to the left, all right, of the dot notation, okay? So if we take this back to the concept I will just explain with object.create, let's imagine that this is that's so person, take it back to person, and then this will be human, right? And that's true. And then this will be get codes, and then the function. And to get codes, we say this dot codes, right? Okay. So even though I can get rid of this, it's too much code, and I can just do this, all right? So even though code does not exist as at the time of the creation um, of this object, there's not going to be an error because um, this hasn't been invoked, all right? It's not been invoked, okay? So there's no error until I invoke it, and then we can get undefined because there's nothing like quotes, all right? And we know that. So let's try it. Let's do person. So first of all, we need to do const Austin equals object dot create person, all right? And let's say Austin dot get quote. Okay, so if we try this now, we should expect undefined. Why is that? All right. When we say this dot code, we're saying Austin dot code, right? And the truth is that Austin has no code. So what happens when you try to access a property that does not exist in our object? You get undefined. All right. So this should make sense. You should always be able to explain the outputs that you get in your program. Whether it is an error, whether it is, you should always be able to explain it. You should know how it came about. Okay, that's why I had to explain that. So what we can do now is to say that we want to assign, a code to the Austin object, and then we call this we say none for now. So now if you check, we get none for now because there is now that property in the object Austin. Okay, so I get it. All right, so these are three different ways to create objects that I've shown you. Number one is to use the normal um, object syntax, which is this. Number two is to make use of constructor functions. So you call the function with the new keyword, and then it will return an object. All right. And number three is to use object.create. So with object.create, you are passing in the prototype. All right, you're passing in the prototype for the object that you want to create. All right, so let's talk about the concept of prototype. I hope that just give me a minute. Let me try to contact the next instructor because I need more time. I want us to start Node.js from Monday, so before Node.js police will come and arrest us. So just give me a minute. Let me All right. Okay. So, where was I? I was going to talk about prototype, the concept of prototype. So let's say we create an object ordinarily, but without all these fancy syntaxes that I've shown you. So this would be an ordinary object, right? What is the prototype of this object at this point? Note that we did not specify the prototype, all right? So if we had done the new keyword and stuff like that, we would have specified the prototype. Object.create, we are specifying the prototype. New keyword with a function, we specify a prototype, all right? But with this is just the normal syntax for creating an object. So what would be the prototype, all right, in this case? So let's find out. We can do that by simply logging this guy to the console. So I'm going to log this to the console. And so if I spread this out, so we see prototype, all right, and that prototype is what? Object. Okay, and then if I expand, we're going to see a lot of things that we have access to. So let me explain. When it comes to JavaScript, all right, okay. When it comes to JavaScript, right, there is like a function called object. So this is a function called object, all right? And every object in JavaScript is constructed from this object, okay? So when you create an object, it is like you're constructing from this object. It's like you're doing, it's like what we did here was object dot create, okay? That's like what we did there. So object dot create, but then we did not specify any properties for the object. So object dot create will not specify any, what's it called, prototype. So it's going to take the object as its prototype. All right, that's what we did there. So what that means is that this person object would inherit properties that belong to this object constructor. All right, and what are those properties? What do they look like? These are what they look like. Constructor has own property, is prototype of properties, numerable, and all this stuff. These are the things that you have access to. Even if you don't have them directly indicated on this object, right? But you have access to them because you are inheriting from the guy called object, this big guy called object. All right, that's what you are inheriting from. Okay, so that is why you could do something like dots. What do I have here? To string. All right, so if I say to string, person dot to string, and then we check, you see that we have object. All right, so we're able to use. It did not try an error because this is valid. All right, so we're able to use person. Okay, dot to string, even though person as this object originally does not have anything called toString in it, all right, as a property. But because it inherits from this top level object, right, it now has access to those properties, all right? So this is what happens to arrays too. So an array, right, we have what is called the array constructor. Well, array constructor is inheriting from objects. So every of these guys, you see numbers, strings, and all those stuff, they inherit from the top level objects. Okay. But then they are also constructors themselves. That means you can construct values from them. Okay. So let's work with array and see. All right. That's why if we create an array, 1, 2, 3, 4, 5. What is happening behind the scene is that we're using the array constructor, which is this guy, array. And then that makes it the prototype for this person. So if I say person dot, no, let's just construct person now and see. If I say person, you see your object, your array here, right? But then if I expand it and check the prototype, what is that? The prototype is array. All right, that means it's inheriting some properties from something called array. Okay, if I expand to see what are the things I have access to, you see that I have access to stuff like art, concat, all right, entries, fill, find, all right. I have pop, push, reduce. You see the reduce that we used, right? Shift, reverse, and all these things that we have access to. It is because we are inheriting from somebody, which is the array prototype array behind the scenes. So if you have ever wondered, how is it that we are able to call person dot reduce, all right, on an array? Even if physically, like with your naked eyes, you cannot see anything like reduce attached to the array. It is because arrays are created from this array prototype. And this array prototype has some properties in itself, all right? And when something is created from a prototype, it's going to inherit the properties of that prototype. All right. That's why all humans, we have some similar properties because we inherit from the same source. All right. So that's the explanation for that. Reduce. Okay. So let's assume that I think during one of our classes, we tried to reproduce reduce, right? I think we tried to reproduce reduce. So let me show you something. The prototype is array, right? But if I want to just directly display that prototype object, I'll use something called proto. So you see, person.proto, right? So if I expand, you'll see that I just directly gained access to all the things that we have in the prototype. All right, so proto is a way to access the prototype. It's a very funny name, right? But then that's it. Underscore underscore proto underscore underscore is a way to access the prototype. Well, now, since we all know that there's something called prototype that we are inheriting from, don't you think we can add our own properties to array? So let's do something. I'll say array dot prototype, right? Dot array version equal to 2.0. So this person now, right, is an array. So if I do person dot array version, let's see if it's going to work. So log 2. All right, it's supposed to be 2.0, but yeah, it's just rounding off. So version 2. All right, we can even make it a string. All right, version 2.0. So 2.0. So this now works. If I create any array in my program, it's going to have version 2.0. Let's try it. So if I come here and say person 2, all right, irrespective of the value, let's try to check person 2 would have something called
We cannot hear you, sir. We can't hear you again now. I don't know if I'm the only one. We can't hear you, sir.
Yeah, can't hear him. I can't hear me there.
Talk is breaking.
In that array, I think my internet has started again. Can you hear me? Confirm. Can you hear me now, guys? Yes.
I can hear you now. You went up before.
Okay. All right, great. Sorry about that. So so now we're saying that array.prototype, we want to add a property to you, right? Called array version. And it's going to be 2.0. Okay. So what it means is that this array.prototype, which every array is created from, all right, we are now modifying it and saying that it should have an extra property, which is called array version. All right. So now if I do array dot console dot log array dot pro, so all right. So let's see. Okay, it's a function. It's a function. So no, what we should be doing is passing dot proto, right? Yeah. So let's check. So you can see that it now has array version 2.0. Ordinarily, JavaScript does not provide anything called array version. But because we know that all arrays will be created from array.prototype, all right, which is an object, and it will inherit all the properties in array.prototype, we can now add our own properties to it, all right? And every array will have that property. So how would this make sense? Before I proceed, I would like to let you guys know that this is strongly discouraged unless you know what you're doing. Or maybe you're creating your own library like jQuery and stuff like that. All right. Then you really know what you're doing before you can mess with this prototype. All right. But don't just feel excited and then start adding your own stuff to array prototype. It is strongly discouraged because you might get unexpected results because you do not fully know what you're doing. All right. So this is just to show you so that you understand what's happening with objects in JavaScript generally. All right. So let's say that I want to test my knowledge when it comes to JavaScript. I want to test my knowledge. So I know that there's something called reduce. So if I get rid of all these guys, and let's check this prototype, we see that there's something called reduce, right? That JavaScript has, reduce. I want to create my own version of reduce. I don't know how this reduce works. I really don't know, right? But I want to create my own version, okay? To test my knowledge of how it works. So what can I do? I can simply create a function called reduce. But now I'll just call it v2, right? Version 2. So I'll say reduce version 2. And then reduce accepts a function, we all know. And it accepts a function and an initial value, all right? Function and initial value. And what it does is that, I hope I'm in the right headspace to reproduce this. All right, so let's do this. What it does is that it is going to loop, all right? That's one thing I know it does. It will loop through, so it's going to take an array, right? So this is our version now. To take an array, take a function, and then initial value. So what it does is that, so let's say, let I equals 0. It's going to loop through that array. So as long as I is less than the array length, all right, we are going to run this code and then increment I, all right? So what's the code we want to run? So we're going to run the function, all right? But we'll pass in two things into the function, right? We want to pass in the current item of the array, the current item of the array. Is that what we'll do? Current item of the array. So let's do so what happens in reduce? So when it runs, right, we're going to get the accumulator and the current value, all right? So we'll pass in something accumulator into here. All right, and then so there'll be a function that takes in an accumulator, and then the current value, right? Current value. But where do we get this from? So the current value is going to be the array 0, no, array I, right? But then the accumulator is going to be the return value of function. So what we'll do is that we're going to have something here called let accum, all right, equals 0, okay, equals initial value. Right? So accumulator is going to be passed in here, all right. So that is it. Are we doing good? Let's see. So array I accumulator will be passed in, and then the result is going to be assigned to accum. Okay. I hope that makes sense. So let's try. Let's try something. Let's do person.reduce version 2. No, we can't do dots. I'm sorry. So what we can do is reduce version 2, and then we'll pass in person into it, and then pass in our reducer function and our initial value. So what will be our reducer function? So that will be function. I can decide not to give it a name because it's being used immediately here. So it could be anonymous. So it's going to be a function that takes in the cum and the current value, and then it returns accum plus current value. So let's see. And we return accum. Okay. And then so let's console.log this guy and see if we're written rubbish or not. Okay, so we didn't write rubbish, it worked. All right. So let's see. 1 plus 2 is going to be 3. 3 plus 3 is going to be 6. 6 plus 4 is going to be 10. And 10 plus 5 is going to be 15. So our implementation of reduce is working. All right. So this is our own implementation of reduce. But having the understanding of prototype, right? I know that I can attach my reduce function to array.prototype. So what I could have done is this. I could have said array.prototype dot reduce v2 should be equal to the reduce v2 that I've written. And here, I should now be able to call this like a normal reduce function. So I'm going to get person out of here. And I would say person.reduce version 2 and check if there's an error. Fn is not a function. So let's see. Fn is not a function. Fn is not a function. So here we don't need array anymore. All right. And says array is not defined. So we actually are not using array anymore. Should not be using this. And there you go. My function now works. So let's get this out of the console so it doesn't disturb us. So you see that I have successfully created my own version of reduce. Let's bring it out here and just say result equals this. So this is my own version of reduce. Make it very clean. Let's try to make it very clean. All right. There you go. This is my own version of reduce. And we'll console the log results and you see we are 15. So let's use the normal reduce function. result 2, and we'll call person.reduce, the one that JavaScript gave us. And you see that if we console log result 2, we should be getting 15, 15. Okay, so I successfully implemented the reduce function again. All right, but then let's try to look at what actually happens. So what happened? We're using the concept of inheritance to our advantage here. All right, we know that every array inherits from array.prototype. Every array inherits from array.prototype, right? So everything available, or every other properties available on this array.prototype can be used with our arrays, all right? And one example is reduce. All right, reduce is available on array.prototype. So since we have that knowledge, we should know that array.prototype is just an object. So we can attach new properties to it, right? And so I attached my own property to it. Okay. And we know that when you use the this keyword, this, so you see this we're using now. When this is being used, right, it's going to actually refer to the object on which it is being used. And that object in this case, it's person. Remember, this is going to be the object to the left of the dot operator. So when we're saying this inside here, right, we'll be referring to person or any object that this guy is being called on. Remember, arrays are still objects in JavaScript, so that's why JavaScript is funny. Okay, so this keyword is going to refer to whatever is on the left of the dot notation. Because of that knowledge, I was able to do this dot length. So it will refer to any array that we use our function on. All right, and everything works. So you can take some time, look at it, and it's going to make more sense. Okay, so at this point, sorry about that. At this point, I'm going to take questions before we move into classes quickly. Let's just do a bit of touch on classes. If I have time, I'm going to record more videos on this prototypal inheritance and classes if I have time. All right, I'm going to try to do that before Monday. All right, but by Monday, surely we're getting into Node.js. So before you prepare your questions, no audio again. Okay, that has to be the old
We can
message.
hear you.
All right, good. So while you're preparing your questions, what was I going to say? The videos from the last session, sorry, has been updated on YouTube. All right, it's been updated on YouTube. So let's, in case you haven't seen it, because I'm sure a lot of you guys have not seen it. So let's do Zuri team, and you will go to playlists. Okay, so these are the, go to Node.js. All right, just search these 3 playlists. Anywhere you see green, I think that should be my computer. It's teal color. So just check those playlists and you will get your hands on the video. All right, so that is it. All right, so questions. If you are confused, let me see you drop. Just drop C on the chat. If you are confused, C on the chat. C. So we have 2 C's. Ah, you guys want to form a C. A C of C's. All right. even comfy, you are not comfortable with the concept. Okay. All right. So I have a video. I think I have a very clear video on the concept of reduce. All right. Perhaps you missed that class. So let me so let's go back to Zuri, right? Sorry. Team playlists. And let me see. Hope I can find it. Just it's no, it's not what it is. Let's see. Yes, so there's filter. Where are down now? There's map, there's reduce. Okay, so I'm gonna copy this playlist and send to the chat. So all those are methods. I'd explained them before, except you missed the class. So you're going to find them in the playlist. That's for promise. Promise. So for the rest, guys, we have 6 C's. Yeah. Well, that's a pass mark. Out of 20 students, we have 6 C's. So 14 understands. Or maybe they're not confused, but they don't understand, but they're not confused. But it's fine. It's a normal thing that happens, right, when you're learning programming. So just go through the videos again. Go through the videos again, and it's hopefully going to make more sense. Okay. So somebody said on the group that we've never gotten into the deep concepts of JavaScript. That guy must be a pro because these things we're explaining, they're not cheap. All right. All right. Maybe he has an understanding perhaps somehow, but they are not not deep concepts in JavaScript. These are serious concepts that if you understand, they consider you a serious JavaScript developer. All right. So it's okay if it doesn't really make complete sense. All right. At the first time I'm attempting to explain it to you. So I'm going to promise, because of these guys with C's, I'm going to promise to record other videos to to enhance what I've taught on this one. Okay. So I can clear your doubts. All right, let's go into the concept of classes. Classes. Concept of classes in JavaScript. Now, a class is an improvement when it comes to inheritance in JavaScript. Classes are an improvement, right? Usually, the raw way to implement the concept of inheritance in JavaScript is by using prototypes. That's the raw form. All right. So you start writing prototypes everywhere, and it is usually confusing. Even professional developers, when I mean professional, I mean experienced developers now, that's the word to use. They are usually confused with this prototypal stuff, inheritance stuff, right? So because of that, the organs of JavaScript came up with a class keyword, all right? So you have a class called person. All right, so a class is simply a blueprint for other objects. That's what the class is. So this is mostly referred to as a syntactic sugar, all right, for the concept of prototypes. Okay, so what it means is that behind the scene, classes implement, prototypal inheritance, okay, or the concept of prototypes in JavaScript. That's what it means. So you have this keyword, very clean, class person, and this class is going to have a constructor. It's going to have a constructor, okay? And inside the constructor is going to expect some initial properties for your object, all right? So like your name, like your age, all right? So inside the constructor, we say this.name equals to name, and this dot, what's it called now? Age equals to age. So if I save, I simply need to create a person object, all right, like we did before, Austin. I'll just say Austin equals new person. And if I console the log Austin, I'm going to get name undefined, age undefined. And why? It is because my constructor, this is your constructor here. The constructor expects you, see as I hover on it, right? It expects you to pass in your name and your age, and I did not, okay? Because whatever you pass into name is going to be the value of the name in the created object. And whatever you pass into age would be the value of age in the created object. If you miss this, you get undefined. So what I do is just say Austin and 12. Okay? So now I have an object with name Austin, age 12. And if I check prototype, it's object, all right? The constructor is class person. All right, so who is the constructor? Is the class person. All right, that's what this object was constructed from. Okay, so what that means is that you're going to inherit everything that that class, has. Everything that the class has, you're going to have access to it, plus everything that object has. All right, so that's the way it works. Because person actually falls under object, all right? An object is the last guy, okay? So the inheritance is going to fall like that. So what I'm saying in a nutshell is that object is like the grandparent, person is the parent, while this object I just created, this Austin object, is the child, okay? So you're going to have access to the properties of object, which is the grandparent, person, which is the parent, and yourself, all right? Your own properties. So if I start to do things like Austin dot I color, for instance, and say brown. No, my color is black. All right. And say black. I now have I color as black, right? And then I still have access to all these um fields, all right, or properties. So how do we write methods for classes? I would like you to compare this syntax with when we use functions. All right. Compare the syntax with when we use functions. When we use functions, follow me. Remember that we use constructor functions, right? I call them constructor functions, right? See, watch. I'll just say function. I'll change the name to person, and I'll get rid of the class. Save. See, exactly the same thing. This is how I want you guys to be thinking. When you see things, you can say, oh, what's the similarity between this and that, and get it. So this is a constructor. So when you say class is a syntactic sugar, it just covers, all right, the actual prototype inheritance, which is when you use functions, you're actually using prototype inheritance in a sense. So the class will just wrap it. So this is a constructor function, right? Let's do something now. So the class is going to wrap it. So if I say class person, okay, and then I put the constructor function inside, but in this time I call it constructor without the function keyword. You can't have functions inside classes. So without the function, I'll just call it constructor. And the same thing happen, right? But then you can forget about that syntax. What is advisable according to conventions is you stick with classes, use classes. If you ever want to implement the concept of OOP, object-oriented programming, use classes. If you don't know what to do, unless you really know what you are doing, then you can use other methods. But just try to understand classes and stick with it. So if you forget any syntax, don't forget the syntax. All right. So you use class keyword, the name of your class, and note that this is in cap locks, right? And then your constructor function. Okay. Now in this case, if you want to add methods to your class, you want to add methods to your class, what you can now do is you add the method like this, get quote. All right. This is a method, so you can't use function keyword. Always remember that function keywords cannot be used in a class. So if you see a constructor method accessor, blah, 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 so unexpected token, you can't use function keyword inside a class. So your methods are going to be without that function keyword, but every other function syntax remains. Okay. So get quotes, you could say this return is dot quote, right? And console log dot eye color, we get black. That's correct. We console log get quotes, we get undefined. That's correct because this object does not have anything called get quotes, so we can create it. Get quote because life is just filled in the blank space. All right, so this is this dot quotes, and you're returning get quotes. This is the get quotes. Oh, sorry, this is the quotes, quotes, quotes. All right, so life is just dash, dash, dash. Okay, so this is classes. A very, very clean way to write programs. So how is that? How is that even? Let's assume that we have a class called, we have a class called JS. Let's just call it JavaScript class. Oh, JavaScript 101. Let's just call it JS 101. All right, so our class is JS 101. Okay. The things that are going to be in this constructor are things that would most likely differ between students. All right. So you can create students from this class. Okay. You can create students from this class or courses from this class. All right. So the course name is most likely going to be different. The course duration. So duration. Right. So the course duration is going to be different. Right. The things that are most likely going to differ, those are the things you put in this constructor. So when you're constructing it, it will be unique from every other course. Right. So I have the course name. Let's just call it title. Course title. Okay. And then what are the things you can do with a course? So you can register. All right. You can register for a course. Right. When you register a course, what we simply want to just do is say console log you have registered for this for, so let's this dot title. Okay. Right. And then when you cancel subscription, so let's just call it subscribe. Right. So you say you have successfully been unsubscribed from, right? So you say you have subscribed to, all right? So let's do it like this. So now this is a JS 101 course, right? And it's going to have different classes. Okay, it's going have different classes. So if I use the word class, don't confuse it for this. So just think in the concept of what we're doing now, or let's call it lectures. All right, lectures. Assuming you're building a Zuri dashboard, so you have something like this lecture. So lecture. So what's the lecture and what's the duration, right? And then they are going to have different links, right? So course link. Okay. So we could do something like this dot course link, course link, right? So now what we'll do is I want to create a course. So we can now create different lectures. So I want to create a lecture. I want to create different lectures. So this is going to be let's call it lecture 101 or lecture 1. The lecture 1 is going to be new JS 101. Right? What's the lecture title? The concept of inheritance in JavaScript. All right, that's the title. What is the duration? Let's say it's gonna be for 1 hour. All right, and then what's the course link? Google.com. Just leave it like that. Okay. So I've created that lecture, so we can create more lectures, as many lectures as we want. So lecture 2, the same thing, new JS 101 lecture. All right, and then it's going to be how variables work in JavaScript. 1 hour 30 minutes. Wow. 1 hour 30 minutes and meet. Please mute your mic. Please mute your mic. All right. So I have 2 lectures, right? And then you can simply just log your lecture. Lecture 1. This is the lecture that we've created. Okay. Lecture 2. That's the lecture. All right. So if I want to unsubscribe from lecture 1, I'm going to say lecture 1 dot cancel subscription, run the function. And it's just simply say you have successfully unsubscribed from. It says undefined. So we get this wrong. This is lecture, right? So successfully unsubscribe from, it's still saying undefined. So let's see why is that. This is the lecture is gonna be that.
The second one, unsubscribe.
Unsubscribe. Okay, yeah, I
second.
think it's yeah. Yeah, so you're successfully unsubscribed from how variables work in JavaScript. So you can do some fancy stuff here. Is that how to do it? Do I recall how to do it? Yeah. Okay. So I think it actually works without this because I'm using, yeah, it works. So you have successfully been unsubscribed from how variables work. So what would have happened now is maybe inside this function, I would be calling the database and then unsubscribing the user. So inside this function, sorry, cancel subscription, I would access the database, then unsubscribe the user. All right. Unsubscribing the user would simply be just updating a table column, right? User and say
We
subscribe
can't hear you.
false. And
Can't-
then I do some refunds, all right? If they're eligible for refund, network. Can you hear me now?
Yes.
All right, great. So yeah, unsubscribing the user we are simply just logging to the console now, but we could be doing a lot here, right? We could be doing a lot. So we could be accessing our database, right? And then when we access the database, we update the user. We update the user data. Please hold on, please. Hello, guys. Please, if you can grant me like 5 minutes, please. I need to take care of something over here. 5 quick minutes. I'll be back.
Okay, sir.
All right, sir.
All right, guys. Please confirm if you can hear me.
Yes, we can hear you, sir.
I hear you loud and clear.
All right, thank you. So canceling subscription could be, accessing our database, updating the user column, all right, to maybe subscribe false, all right, and then process, what's it called now? Chargeback, all right, or refund, okay? Process refund, and then send user email, send user an email, all right. Sorry, I start to let you go, blah, 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 or to see you go and stuff like that. Okay. So it could be a lot happening here. Yeah, we're just simply console logging, right? Because that's not what we're doing now. So when we start doing Node.js, we'll get into all these things, right? If we write our programs using the object-oriented concepts, you're going to see a lot of things like this. We write a class, that class will expose methods that we can use to, change stuff, right? So these are things that we're going to see a lot. Yeah, so classes provide a way for us to group our functionalities. So you can see that this is a course, all right, JS101 course, and then everything that has to do with that course lives inside this class. So you can see that it's like a neat way for us to group functionality. So if there's a class, everything has to do with that class lives inside that class, right? If there's another class for let's say tutors, right? Everything for onboarding a tutor, all the functionalities will live in that class. All right. So that's the concept of object-oriented programming. You orient your program with respect to objects. So you see that this classes are simply stuffs that create objects. So you can see that the use of this class, right, is to create objects. So we can create different objects from it. Okay. This is going to make more sense when we start working with Node.js. But that's the concept in a nutshell of a class. Classes have fields, all right, and then they have methods, okay? When you create an object from a class, these fields becomes properties, all right? And then the methods are methods, all right? They stay as methods, but those your fields are going to be converted to actual properties in the object, as you can see here. So if we go lecture 1, you will see that all the fields have been converted into properties. But you see that the methods are not really visible, like they're not stuff that you can see, right? But if you go down to check more, you see that you now have cancel subscription, we have subscribe, and we have the constructor, okay? Which is this. So that is simply the concept of classes. All right. Talk about OOP more when we start dealing with Node.js. But if you have questions, I will take them now. I feel like classes are more easier to understand, right? They seem more natural to explain. So I think it will be easier for you guys to understand classes.
Hello.
Yeah, I'm with you. Who are you speaking?
Okay, thank you very Dominic.
Okay, Dominic, yeah.
Yeah, thank you very much, Mr. T. So when you were talking about prototypes, you talked about inheritance. So how is it implemented in classes?
All right, so in classes, thank you very much for that question. I was going to skip that. So in classes, if you want to inherit, let's say that we have, I think it will be easier to reason about it with humans, right? Let's say we have a human class, okay? And then name and age. And let's get rid of course link. We don't need too much to explain the concepts. Okay. So let's say we want to create a person class, but we want person to inherit from humans. So what we'll do is say extends humans, right? What have we done? What I've simply done is that we have said that person should have access to the properties all right, that exists in the human class. So you use the extends, all right, to do that. You use the extends to achieve that. So this extends keyword. So you say person is a class that extends the functionalities of human. That means it will start from where humans stop. That means it has access to everything that has to do with humans and continues from there to create its own. All right. So I think somebody's maybe watching the recording again. Yes, definitely. All right. And then it will say constructor. Okay. All right. And we write our stuff. So we provide, so what do we provide here? Name and age, right? So name and age. And then let's just say eye color, all right? And then we call super with name and age. So now if I console the log, so I want to create a person. Let's create a human called a human called let's just call it Patrick. And then we say new human. All right. And then we're supposed to pass in name and age, right? So passing name. Name would be us Patrick. And then age will be 12. And that is all. Okay. But then I forgot to write this one there. But then I want to call Austin. I want to create Austin, but I want Austin to be a person, not just a human. All right. Austin is going to be a person, and it has an extra property that needs to be specified called eye color. You know, say black. So now if I log Patrick to the console, Patrick, and then log Austin to the console, let's see how they both appear. All right, so you have Austin as, you have humans, which is Patrick, name Patrick, age 12. But for Austin, you have not just name, but you have age and you have eye color. All right, that's the concept of inheritance. So we're continuing from where humans stop, okay? But then what is very, very interesting now is that humans, provide cancel subscription and subscribe, all right? And if we check person, watch now. Person has a constructor of class person, okay? And then if we go down, you see that the prototype for this person is actually humans, right? And if I expand, you see that I have access to cancel subscription and subscribe. Okay, so I now inherited those methods from humans because of this extending that I do here, extends, and this is the concept of inheritance, right? So you can extend a class, all right? So you inherit the properties of that class, even though person class does not have these methods, all right, in it, but because it is inheriting from humans, I can actually use the methods within the person class. So every instance of the person class can make use of that method. All right. So I promise to actually record other videos to support this introductory video, right, that we have done now. And I'll try to bring
Hello,
this.
T.
Yeah.
This is the second time you mentioned instance. Then I haven't quite explained what an instance is.
Okay. Okay. Let me just answer this last question before we go. All right. So what's an instance? Yeah. How do I explain that? All right. An instance. So an instance is can I call it a clone, right, from something? So when I say an instance of humans, I'm saying a clone, all right, or a product of the human class. So I think that's the right word. A product of. When I say instance of, I'm saying product of. All right. So I think that's what makes sense. So if I say Patrick is an instance of human class, I mean Patrick was created from the human class. All right, that means it's a product of the human class. If I say Austin is an instance of the person class, it means Austin was created from person class. What is actually another way you can actually um, um, understand instance, right? When you say something is an instance of another thing, it means that other stuff, it's its prototype, all right? That means the blueprint of it is that stuff. So if I say Austin is an instance of God, it means that the blueprint for Austin is God. That means Austin was created from God. Do you understand? So when you say instance of, you're saying that this is a product of this, or this was created from this. All right. So that's the simplest way I can explain it. I don't know if it makes sense. I don't know who asked question.
Yeah, yeah, those. I think I get the idea.
All right, that's fine. Okay, guys. So that would be the last question for today's class. I'm going to record. I'm going to apologize. I think the person in charge of uploading videos, I think is really occupied. All right. At this time, so that's why the videos are coming in very slowly. Right. I hope that it gets better. All right, but I will try my best to record the videos and send and follow up to ensure that you get the videos on time. Thank you very much, guys. Have a nice day.
So much.
Thank you, sir.